So let's briefly go over some of the post-lab analysis for this lab involving intermolecular attractions and their effects on evaporation, the first lab in General Chemistry 2. What I've done here is sort of made a tabulation in Microsoft Excel. You do not have to use Excel. You can just use pencil or pen and paper for your lab report and sort of overlay the data. So one of the questions in the lab asks the differences between the intermolecular forces between alcohols that have the OH group and the alkanes, which are straight chain hydrocarbons, just carbon and hydrogen. They're just straight chain pentane with 5 carbons and hexane with 6 carbons. And here's our change in temperatures, maximum minus minimum, that we calculated. You can see here that the very simple 1-carbon alcohol methanol has a change in temperature of 14.8 degrees. But remember, as we go from methanol to ethanol, propanol, and butanol, we are increasing the number of CH2 units. And you can see here as we graph this as a function of molecular weight, obviously you increase the CH2 units, you're increasing the weight of the corresponding alcohol. You can see the trend is that the delta T goes down. Let's talk about the alkanes, pentane and hexane. We kind of see the same trend. More molecular weight, more dispersion, and we see a lower change in temperature. So butanol would have the strongest intermolecular forces and the lowest delta T, right? More number of carbons, more mass, and that OH group for hydrogen bonding. Now, the biggest difference is in butanol and pentane. Pentane, 5 carbons, pretty low molecular weight relative to others, but no hydrogen bonding, only dispersion. So in terms of weakest intermolecular forces amongst the alcohols, you're going to say methanol. Strongest intermolecular forces, butanol. In terms of the molecular forces for pentane and hexane, hexane, 6 carbons, pentane, 5 carbons, more mass, more dispersion, more of a barrier to overcome for this to evaporate.